Hello everyone, welcome to my channel. So, as we are already done with the concept of arrays explanation along with representation of arrays explanation, so now we'll quickly jump onto the problems primarily because like the movie saw DSA, the movie will understand and know the concept. So it's better we jump onto the problems now, and I have decided to follow this sheet. This is a SD sheet from Love Babbar which we are going to solve because primarily we don't want to waste our time over problems which are not that important. So that's why we are going to follow this sheet. The sheet contains some very good problems. So in the array topic, as you can see, there are many problems. So the problem we are going to do now is this one, which is marked as very important. That is Kadane's algorithm. So first we'll look into the logic for this problem followed by the code. So let's get into the explanation. So this is the problem which we are going to see right now, that is Kadane's algorithm. So let's quickly go through the problem statement. It says like given an array of n integers, so find the continuous sub-array which has a maximum sum and return its sum. So what do we need to do over here? We need to return the sum of the maximum sum of the subarray from the given array. In the given array, which subarray has the maximum sum? So we need to return that maximum sum. Okay. Okay. So over here, it's given 1, 2, 3, minus 2 and 5. Right. So over here it's given as 9 because it is taking the sum of the entire array. It's 2, 3, 4, 5, 6. 6 plus 5 is 11. 11 minus 2 is 9. So it is 9. If we will take the any other subarray sum like 2, 3, 1, it's 6. It's less than 9. If we will take if we will include minus 2, it will be 4. It will again be less. If you will take the entire sum, then only it will be the maximum. Now over here, if we'll take this example, if we'll take this example, it will be if we'll take the sum of just minus 1, it will be minus 1. If we'll take these first two elements sum, it will be minus 3, which is less than minus 1. If we'll take the sum of the first three elements, that is minus 1, minus 2 and minus 3, it will be minus 6, which is again less. So that's why like minus 1 will come out to be the maximum sum for this array. Okay, so it includes just one element, that is the first element minus 1. So you'll get a clear clarity when we'll dry run through this example. So let's take the first example itself, that is 1, 2, 3, minus 2 and 5. So we are going to take two variables over here, that is maximum so far and current maximum. What is maximum so far going to store? It will store the maximum sum of the subarray till now. It will store the maximum sum of the subarray till now, and current maximum will store the current sum of the subarray. Store the current maximum sum of the subarray. Okay. Yeah, so you will get more clarity of these variables once we start dry running. So both of these variables we have initialized them with the first element of the array, that is 1. Okay, so this k we'll see when we start dry running. So now we'll run the loop from the second element. Why from the second element? Because we have already initialized, we have already taken the first element as the maximum sum till far, as well as the current maximum. We have already used this first array element.
Now, so we'll run the loop from the second array element, that is 2. So now what we'll do is we'll take this, now we'll find the sum of the current maximum. Current maximum till now is 1, and we'll add it with the current array element, that is 2. So 1 plus 2, it will come out to be 3. Okay, it will come out to be 3. So this k will contain 3. So now we need to check which is greater. This 3 is greater, or this current array element is greater. Which one is greater? 3 is greater. So this current maximum will store 3. Now we need to check this maximum so far has 1 till now. Like, is this maximum so far containing less value than current maximum? Yes, it is. So we'll store the value of current maximum and maximum so far. Okay, so now we'll iterate to the next array element, that is 3. So now we'll again add the current maximum, that is 3, with the current array element, that is 3, which is 6. So this 6 we are going to store in k. And now we'll check, is this 6 greater or 3 greater? Obviously 6 is greater. So we'll store 6 in the current maximum. Now we'll again check, like, whether this maximum so far having less value than current maximum. Yes, it is having less value. So we'll store 6, like that is the value of the current maximum and maximum so far. Now we'll iterate to the next array element, that is -2. So now we'll add this -2 with 6, that is current maximum. It will give us 4. So now this 4 will be stored in k. Now we'll check whether this 4 is greater or this -2 is greater. Obviously 4 is greater. So we in current maximum will store 4. Okay, so now again we'll check for maximum so far. Is 6 greater or 4 greater? Is maximum so far having a value less than current maximum? No. So we are not going to initialize maximum so far with current maximum value. And now we'll iterate to the next array element, that is 5. So now we will again add the current array element with the current maximum, that is 4. It will be 9. So this 9 will be stored in k. So now we'll check whether this 9 is greater or this 5 is greater. Which is greater? This 9 is greater or this 5 is greater? Obviously 9 is greater. So we'll initialize current maximum with 9. So now we'll check whether this maximum so far is having a value less than current maximum. Yes, it is having value less than current maximum. So we'll initialize maximum so far with the value of the current maximum, that is 9. So now we are done with the array elements. So our answer, or the maximum value of the sub array, maximum sum of the sub array is 9, which will be stored in maximum so far variable. So our maximum so far variable will contain the answer for this program. I hope you've understood this. I have an algorithm to show you so that it will be easy for you to understand. So let's see that. So this is the algorithm which I was talking about. So this is, I have actually written the steps which I've explained in the previous explanation. So like over here, the first step is we need to take two variables, one to store the maximum sum till now and one to store the current maximum sum. Okay, then we need to initialize both of these variables with the array first element, and the third step is we need to loop from the second array element till last. Okay, and during each iteration we need to get the sum of the current array element and the current maximum and store it in the variable say k. Okay, so now we need to check whether this k is greater or the current array element is greater. Whichever is greater, we need to store it in current maximum. So now we need to check whether this max so far is having a value less than current maximum. If yes, then we need to initialize maximum so far with current maximum. So at last, this maximum so far will give us the maximum subarray sum. Okay. So this is actually a very important algorithm. It's a base to many programs. So make sure you understand this algorithm very clearly. Okay. So next we'll write a program. We'll quickly write the program for it. So let's start writing the program for it. While writing the program, we'll make sure that we follow each and every step in the algorithm. Uh, okay, so first we'll take two variables, that is max so far and current maximum. Okay, so now we'll take both of these as long. Okay, so now this max so far, we'll initialize it with the first array element, that is array ARR of 0, and same for current maximum. We'll initialize it with the first array element. Okay, so now we will iterate from the second array element to the last. Now what we'll do, we'll get the sum. We'll get the sum of the current array element plus the current maximum, and we'll check if k is greater than the current array element. So if k is greater, we'll assign the current maximum with k, else we'll assign current maximum with the current array element. Okay, so next we'll check if max so far is having a value less than current maximum. If yes, then we'll assign max so far with current maximum, and at last we'll return max so far. Okay, so we have written the program for this. We have followed the algorithm which I have mentioned step by step. So now let's compile and see if it gives us the desired result. It's giving us, okay, it's giving us this error. Here we need to mention this k as long. Why we are mentioning as long? Because over here we need to return a long value. That's why. Otherwise we can take it as int. See, it's giving us the exact value which is needed. Now we'll try to submit this solution. Yeah, so it's already accepted. So I hope you understood this program. If you have any doubts, you can ask me in the comment section below. If you like this video, don't forget to subscribe this channel for more such content. Bye. See you in the next video. Till then, keep programming. Bye.